ATC2000 is a low-noise heating system for maintaining animal body temperature during experimental procedures. The ATC2000 uses a digital PID controller to regulate the application of power to the heating plate in order to achieve the desired temperature at the monitored sensor. PID stands for proportional, integral, and differential, and here's how PID control works. The default set point is 37 degrees Celsius, but you can configure it. The controller calculates the error, which is the difference between the present temperature and the desired temperature. 3 individual components are derived by applying different functions to the error. First, the error is multiplied by the proportional gain factor that you can adjust. The error is also accumulated to constitute the integral, which is multiplied by the integral gain factor that you can adjust. The error is also subtracted from the previous value of the error to determine the difference. It is then multiplied by the differential term, which you may also adjust. These 3 components are then added together to form the stimulus input, which is applied to the system. The system produces a temperature value that is fed back to be compared with the set point once more, and then the cycle repeats until the error is 0, meaning that the output is at the desired set point. The proportional gain is fast acting, and it doesn't change with time when the error is constant. The proportional gain alone brings the system close to the desired value, but the proportional control limits the amount of fluctuation of the temperature around the set point value as the controller stabilizes. However, if the proportional control is used alone after the temperature is stabilized, then the actual temperature approaches the set point but never quite reaches it. Too much proportional gain causes the system to oscillate, going above and below the set point. The integral gain changes with time as the error accumulates. This gain factor changes until the system reaches the set point. At that point, it remains stationary until the error creeps up or down. The integral gain factor is responsible for long-term stability. Too much integral gain can also cause oscillation of the temperature. The differential gain factor is seldom used. This term is mainly used to reduce the initial overshoot in a rapidly changing system. The default factory setting for the differential gain is 0. The functionality is still implemented and available though. For systems with considerable delay in reacting to a stimulus, it may be difficult to use the differential gain factor effectively. To recap this process, the monitor temperature is compared with the set point to determine the error, and then the PID algorithms are applied to the error value. The PID values are added together to determine the command which is sent to the heater. The heater output changes the monitor temperature, and then the cycle repeats. If you have any questions, just give us a call.